Hello, welcome to this video. In this one, we're going to be going over the anti-malware scan interface, the AMSI module that exists within Windows. And this is a basic introduction to antivirus bypassing in Windows, sort of what is this functionality, how it works, and how we can sort of get around it. So who is this for? It's beneficial to OSCP students as it's going to give you an introduction to some of the more sort of advanced topics at real world scenarios. OSCP, as it stands at the minute, doesn't really include a lot of this. I think the most basic sort of form of maybe antivirus evasion that you're going to come across is potentially some ports being blocked by firewall. Not so much antivirus evasion, but obviously something to be considerate of that the firewall is going to be monitoring, so there is that. And this is a good introduction to this sort of topic for yourselves, but it's not absolutely necessary as far as November 2024. There is a new OSCP exam, the OSCP Plus, which is, to be honest, is just a bit of a gimmick, in my opinion, but that's not that's for another video. It's just Offset trying to get money, being a bit greedy. But I don't know if that is going to introduce some more advanced topics in the Active Directory space regarding antivirus evasion. I couldn't say, but potentially that might be the case. So if that is, I'll release a follow-up video focusing on that. But for CRTP students or altered security students in general, if you're starting out, that's definitely beneficial to yourselves, and for red teamers in general as well. This is, as I say, this video is primarily focusing on AMSI, but a lot of the concepts that are going to be covered in here at a very basic level are going to impact antivirus evasion and other things as well, just regarding this topic. So obviously when you're creating your own binaries, even anti-cheat evasion as well, a lot of these are going to come into play across all of them, so it's something to be considerate of. Not so much at an advanced level, but it's just a good introduction to this kind of thing. So what is AMSI? The anti-malware scan interface. It's an interface exposed by the Windows API, exposed to developers, and it's utilised by the operating system itself to mitigate fileless threats. So what does that mean? Essentially, a fileless threat is just something that is immediately loaded into memory or a module, and this makes it a little bit harder to detect, as the antivirus is generally not going to be scanning memory, or it will, but it's just, obviously as an antivirus itself, it's going to typically scan the system, so when things touch disks, they're a lot easier to find and see, whereas in memory, that's infinitely more difficult, hence why this sort of was made. There was a need for this. Not saying AMSI is great, it's far from it. And it needs to be developed a lot greater as the years come on. However, there's a lot of potential with it, even though currently, obviously, it is fairly limited and there's quite a few workarounds to it. It does do at a basic level what it intends to do, and Windows or Microsoft themselves are obviously aware of its shortcomings, as is everyone who utilises it. So it utilises a variety of threat detection functionalities to detect malicious scripts. It's designed to integrate into these functionalities listed here: PowerShell, VBA macros, JavaScript, Visual Basic, and UAC functionalities as well. So obviously when your program's elevating or certain install scripts, this is what's going to run inside those modules. And we will primarily be focusing on PowerShell in this presentation. However, these concepts do apply to other scripting languages as well, such as the macros and the Visual Basic side of things. If it works in PowerShell, it's going to translate over there pretty nicely. So PowerShell and AMSI. When a PowerShell process is created, the AMSI DLL is loaded into its process, as we can see in the bottom left down here. Basically, all this means is that the AMSI is going to implement, or it's going to sort of, the command from PowerShell is going to get sent to this module, and it's just going to act as like a little protector for it. As I've already said, this is an interface that was created and exposed, so it can be used by the Windows API as well as developers as well. So it's not only Windows that can use this sort of functionality. If you're creating a program as well that uses some sort of command line arguments or is passing parameters to it, you can implement this into your programs by calling certain functions, and that's all documented on the Windows API. But at base level, commands sent to the Windows 32 API, AMSI scan buffer. This is the function that's going to take the buffer that you're giving it, so the command or whatever sort of text you're sending it, before being executed to check for malicious scripts. And the general bypass just involves disabling this altogether through certain crafted scripts. There's other ways you can do it as well. You can actually patch out AMSI. If you look at the functionality behind it and how the function works, there's a really good write-up on it through, I can't remember who made it. It was made some years ago now, but it is, again, it's quite a basic bypass, but it's a very interesting write-up. I'll link it in the description as well as some other resources that I'm also going to talk about later on in this video. So in general, it's provided by Microsoft. This is sort of how you can implement the AMSI functionality. So as you can see here, this is our PowerShell and other sort of Windows applications will implement this. They'll go through the Windows 32 API, whereas if you're building your own, other applications represent your own application or a developer's application. They can either implement it at an API layer at Windows 32, or they can use the COM API, so the component object model, And yeah, that's pretty much it. Essentially, there's not too much to talk about here. We're not going to be focused on this side of implementation things. But if you want to look it up as well, it's not particularly difficult to do. You can hook it up straight away if you're using something like C++ in the COM model or whatever you want to do. But yeah, just not the scope of this video. So how does AMSI detect threats? There's three sort of main ways it's going to do it. Obviously, there are going to be other things behind the scenes, but these are the main ones that are going to give you the most headaches. Signature detection, base language emulation, and we're referring to string concatenation as an example, as well as other things as well, and basic decoding emulation. So again, base 64 as an example. So to start off, signature detection, we're referring to string detection and byte scanning. So obviously, if you're using certain commands in a certain way, or if you're using certain strings in your script, such as things like mimikatz, if you're using a default function names like invoke mimikatz, things like that, it's going to get detected when obviously the AMSI module is aware of these, are all stored, so it knows these things exist, so you're going to have to obfuscate those names. As you can see, some available bypasses there: string manipulation, changing names of impacted code, and modifying impacted scripts. So these two are pretty much one and the same. Changing variable names, you can run certain scripts that will obviously obfuscate them for you. And modifying impacted scripts, maybe changing the functionality of it in some sort of way, so basically just finding another way to achieve the same goal kind of thing, and that way it's not going to be SIG'd. So just a very basic example here, if you're uninitiated, let's say I've got this script over here, invoke evil script, and AMSI is detecting this as being malicious. So let's say we want to get around it. As an example, we just rename this function to something that's not signatured, not evil, and then we change the variable name, and then evil command here, not evil. So in this case, let's say it's detecting that this is a malicious function. Let's say this function here is invoke mimikatz. It's going to detect that string there as the function name. So we're going to change that. As well, the commands that we're potentially going to be executing on the strings, we're going to modify them as well, but we're going to talk about that next. So language emulation capabilities, base 64 decoding and string concatenation, and basic string manipulation capabilities. So it doesn't mention it specifically, but I imagine they'll obviously provide functions like, for example, Powershell. You can reverse strings and things like that. I imagine they'll have something like that built into AMSI. But as far as I'm aware, you can actually bypass certain string detections if you use reverse strings. So it doesn't, but you like to think it does. So it's hard to say because the bypasses do work. So obviously, maybe it's not implemented. But obviously available bypasses for this sort of thing, string concatenation and manipulation in general, as I said there. So if you're concatenating strings, PowerShell can detect that. So what you might maybe want to do instead is just pass them in a different way, as I said here, using environment variables, an example I'm going to show soon, or some sort of manipulation. So let's say you'd reverse the string or reverse certain strings and then concatenate them. Maybe it's not going to be able to sort of parse that correctly. And emulate that in the correct manner, so it's going to bypass AMSI scan buffer essentially. Different encoding, base 64 encoding can be decoded by the emulator, so that's something to be aware of. And they rebuild the detect encoded signature. For example, if you're loading an encoded binary within a script and you're trying to load that into memory, why don't you rebuild that whatever module it is that you're trying to load? Because if the signature has been detected and decoded, it's probably been detected as well when it's being decoded, so that's something to be considerate of. In general, different encryption and encoding, so maybe use something like XOR encryption or some sort of other cipher, just something to be aware of there. So here's an example of some emulation bypasses, so for string detection and how to sort of pass parameters to functions while remaining undetected. For instance, here we've got our command here that's been detected, so as you can see, all we're doing is reversing the string here. Instead of being invoke evil CMD, we've now just reversed it, and then this will get passed to whatever function we're trying to execute, or if this is the function name, the function we are trying to execute, if it wasn't parameters, should I say. This is an example provided by Windows. So basically, this is what I was talking about before. If we go back to this, the base 64 encoding. Our invoke eagle function, this is just going to be executing a function here. So let's say this base 64 encoded module has been detected. We'd need to rebuild this, and then as well, if we want to go one step further, potentially we wouldn't use base 64. We'd maybe use some other cipher as well, just for a little bit of added obfuscation. And then down here as well, if we've actually got our module loaded into memory and want to give it some parameters, this is an example that is taught within the CRTP course. We can pass it a batch script, or we can let the batch script run our programs for us. So here all we're doing is setting environment variables in the reverse manner, and then we're just going to pass the environment variables as arguments to our executable here, and that is going to bypass our detection from the antivirus. Lost my mind there. So as an example how AMSI actually works, if we're trying to load a malicious script that it knows is bad, for example power-up, so let's say we want to do some privilege escalation, or just in general this will work for any sort of script you want to run. As you can see, AMSI has rightfully detected this as malicious because there's no obfuscation going on in the script. There's some easy known bypasses that exist for this that are provided after this, and this is one of them. This is just whoever made this, it's just forced an error, as you can see there. So as it's done there, it's forced an error, and then now if we go and re-execute this command, as you can see, it's loaded or successfully loaded the power-up script into memory, and right now it's obviously doing its thing, and it's correctly executing the code when obviously that shouldn't happen, but that means our bypass has actually worked. So some provided bypasses that I'm going to link down below that are really useful for yourselves and students, and I recommend you to go play around with them on your own machine and set up different environments, maybe with EDR and antivirus as well, just to see what things work and what things don't. InvisiShell's a really good one, just an all-in-one thing that works. AMSI.fail, really good resource. It's got a collection of other scripts as well, so you're going to find that not all AMSI errors are going to give you that clear text. It's been detected by malicious content, things like that. Some of them are going to give you other errors that you're going to have to look up. For example, when you're loading some .NET assemblies, they're going to give you different errors that are not going to straight up tell you out of the box. It's been detected by the anti-malware interface, so that's something to be aware of. But as I'm pretty sure I got mine off AMSI.fail, when I was trying to load a .NET module that was detected, it was giving me some sort of different error. I'm pretty sure it came off here as well, but that's something to be aware of and just something you might come across as well. Manually patching the AMSI scan buffer, I don't know how I've managed to crow that, but obviously that is much louder, and that's if you've got an EDR thing on your system, that's probably not going to be the best approach. And there's many other custom scripts online, just look around, and there's all different ones that affect it in different ways, but obviously it's good to know them and have different ones in your arsenal. For instance, if for whatever reason antivirus and EDR is detecting certain ones and not others, that's just something to be aware of. With all this being said, that's just come to the end of the video. It's a nice short and sweet one. Obviously I've not uploaded anything in a while. I hope it's of use to you, and there are more videos coming soon once I've finished with a few things, but thank you very much for watching.